Okay, welcome to 4.5. May I have more, please? And this is a solidify understanding task. So today we are going to read a story problem and we're going to create an inequality based upon the story problem and then solve the inequality and talk about our solutions. So here we go. This is going to be fun. Elvira, the cafeteria manager, has to be careful with their spending and manages the cafeteria so that they can serve the best food at the lowest cost. To do this, Elvira keeps good records and analyzes all of her budgets. Problem number 1. Let's see if we can read this paragraph and translate this paragraph into an algebraic inequality. So, Elvira's cafeteria has those cute little cartons of milk that are typical of school lunch. And those cute little cartons of milk, they existed over 50 years ago when I was in school too. We used to buy them for 5 cents each at lunch. The milk supplier charges 35 cents per carton of milk, in addition to a delivery charge of $75. So our job as mathematicians is, can we translate this into an expression? All right, so first we need to think, what is our variable? Charges 35 cents per carton of milk. I would say X equals the number of cartons of milk. So 0.35 times X would represent this first part right here, in addition to a delivery charge of $75. So we need to add to our costs plus $75 for delivery. And there's my expression. Now, what is the maximum number of milk cartons that Elvira can buy if she has budgeted $500 for milk? So she's budgeted $500 for milk. So let's think about this then as an inequality. If this is my cost right here, and we have $500, then our cost must be less than or equal to that $500 that we have budgeted. Now, there it is right here, and solve an inequality that models this situation. So let's solve it. And you guys are experts at solving inequalities. It's just like solving an equation. The first thing you want to do is undo that addition of 75. What undoes addition? Subtraction. Okay, and now just rewrite your inequality. Let's bring down the less than or equal to. And on the left, we have 0.35x plus 75 minus 75. Those are like terms, and they cancel, leaving 0.35x. And on the right, we have 500 minus 75. That would be 425. Okay, now, how do we undo multiplication? Well, let's divide both sides by 0.35. All right, I'm out of room, so let's go over here, less than or equal to. And on the left, my factors of 0.35 will cancel out, leaving x, and x is less than or equal to. And now, I don't think I'm going to do this in my head. Let's get our calculator out and just carefully punch out 425. 425 divided by 0.35. And, oh, that's an ugly decimal right there. And let's see, this is what? The number of cartons of milk. So let's round that to the nearest whole number, 1,214 cartons of milk. There you go. Write and solve. Nice. Part B. Describe in words the quantities that would work in this situation. So let's describe X has to be less than or equal to 1,214 cartons of milk in words. Well, you could actually read it exactly the way I just read that, but let's add a little bit more to this. So let's go with a blank milk budget, and wasn't Elvira's budget $500? Elvira can buy less than or equal to how many cartons of milk? 1,214. Oh, beautiful. Now write your answer in both interval and set notation. So the interval notation is what we developed in Module 3. And you know that we like to start our interval notation with a comma. And then what's our bound on the left? Well, you look up here and this just says x has to be less than or equal to 1,214, right? But do you agree that we can't buy negative cartons of milk, so I made my left bound a 0. And then my bound on the right is the 1,214. And because Elvira could choose right now to purchase 0 cartons of milk, I'm going to put a bracket right here. That means 0 is a possibility. If 0 was not a possibility, that would have been a parenthesis. And less than or equal to 1,214, we have a bracket on the other side. If there were no equal there, that would have been a parenthesis on the right. And this is interval notation. Set notation. Well, that's nothing more than the inequalities you did last year. And, we have an inequality right here like that. But again, let's add our bound to the left, 0, creating a double inequality. So we're talking our x's, right? And let's see, 0 has to be less than or equal to x, the number of cartons of milk, and the number of cartons of milk x has to be less than or equal to 1,214. And there's our set notation right there. It's just a double inequality that you studied last year. Okay, that's number 1. Let's go on to number 2. Students love to put ranch dressing on everything. I do that too, and that's so unhealthy. So Elvira needs to keep plenty in stock. The students eat about 2.25 gallons of ranch each day. I hope that's a real big school. And Elvira started the school year with 130 gallons of ranch dressing. So let's see if we can take this and come up with an inequality. Let's start with students eat about 2.25 gallons of ranch each day. So what's your variable there? A lot of people might say it's gallons of ranch, but it's actually going to be each day x. So that means, how do I write this algebraically? 2.25 gallons of ranch per day, that would be 2.25x. All right, good. And Elvira started the school year with 130 gallons. So before that first day, Elvira has 130 gallons, and then every day she's losing 2.25 of those gallons, or minus 2.25x. So I'm just going to go 130 minus 2.25x. Okay, now let's see what else we have here. She needs to have at least 20 gallons left. At least. Wouldn't that mean less than or equal to for my inequality? Excuse me, I said that backwards. Greater than or equal to, because she needs at least 20 gallons. Yeah, greater than or equal to 20. Okay, there is my inequality right there. When she reorders to have enough in stock until the new order comes. That makes sense. For how many days will her ranch dressing supply last before she needs to reorder? Well, we can answer that if we solve for x in this inequality. Okay, so here we go then. To solve for x, the first thing I would want to do is get rid of this 130 right here. So can I subtract 130 from both sides of my inequality? And then I bring down my inequality symbol, greater than or equal to. And 130 minus 130, like terms that cancel out, leaving negative 2.25x. Is greater than or equal to 20 minus 130. Well, what's 20 minus 130? Would that be negative 110? And if you're struggling with that, don't hesitate to get your calculator out. You have access to your calculator all the time because you're at home doing remote learning. All right, now, key moment right here. All right, put a star right here because you all know we need to divide by negative 2.25 to isolate this x right here. So we do that, right? But here is the rule. Whenever we're solving an inequality and we multiply or divide both sides by a negative number, we must reverse the orientation of the inequality symbol. Or in layman's term, we're going to flip that greater than or equal to, and it's going to become less than or equal to. Okay, and now on the left, the negative 2.25's cancel, leaving x is less than or equal to. So the number of days would have to be less than or equal to. And now a negative over a negative is positive. But I'm going to punch this out on my calculator. 110 divided by 2.25. And I'm getting 48.8 repeating. So let's think about this now. X has to be less than or equal to, we better put a 48 right there. Nearest whole number. Okay, good. So write and solve. We have part A done. Now describe in words the quantities that would work in this situation. Well, the number of days would have to be less than or equal to 48. You could read it just like that and write it like that, but let's add a little more here. Oh yeah, there's your days too. Elvira will need to order ranch dressing in less than or equal to how many days? 48 days. Now, like last time, write your answer in both interval and set notation. Interval notation, comma. All right. And now, what's my left bound? Well, I know my left bound, I can't go beyond into negative numbers, negative days. That's past tense. So my left bound is going to be a 0. And my right bound would be that 48. Now let me see. Since Elvira could go ahead and put that order in like today, can I put a bracket at that 0? Yeah. And less than or equal to 48 days, I'm going to put a bracket at the 48. So Elvira needs to order her next batch of ranch dressing anywhere from 0 to 48 days from right now. And it will be there on time. Oh, this is so much fun. Oh, don't forget, set notation. Okay, well, let's just convert this to a double inequality. And again, you have it up here, but we haven't talked about the left bound up there when we solve. So, okay, these are all x's from 0 to 48 inclusive. X. And look at the left bound. 0 has to be less than or equal to x. And x has to be less than or equal to how many days? 48. And there's your set notation right there. I'm starting to have fun. Well, let's go ahead and try one more here before I stop this recording and start another one. So, the prices on many cafeteria foods change during the year. Elvira finds that she has ordered veggie burgers 4 times and paid $78, $72, $87, and $90 on the orders. So price went down a little bit, but then went up and is continuing to go up right now. To stay within her budget, Elvira needs to be sure that the average order of veggie burgers is not more than $82. How much can she spend on the 5th order to keep the average order within her budget? So it sounds like we're going to call that 5th order X, and we're going to set up an inequality using the concept of average. So, is not more than $82. Wouldn't that mean less than or equal to 82? There you go. All right. Now, on the left of this inequality, what is not more than $82? The average of these numbers plus that 5th order. And you remember your concept of average. Okay. What do you do? Well, you add up all of these costs. So I'm going to go 78 plus 72 plus 87 plus 90, and that's the sum of the first 4 orders, that cost. And then we have what? $82? Okay, no, that's got to be there. So this 5th order is the X plus X. And now the average of 5 numbers, how do we find it? We add them up and divide by 5. And there's our inequality right there. How much can she spend on the 5th order to keep the average order within her budget? Well, this average with X as the 5th order has to be less than or equal to $82. So now all I have to do is solve this inequality for X. Now, I know it looks a little more complicated right now than what we've done so far, but this is grouping right here. This whole numerator is being divided by 5. So the first thing we're going to do is undo that division by 5 by multiplying both sides by 5. Now we bring down the inequality. And on the left, the 5's cancel. And on the right, I'm going to add up these numbers plus x. So let's add them up. And I don't want to make a mistake, so I'm going to carefully punch this out on my calculator. 78 plus 72 plus 87 plus 90. Make sure that's right. 78 plus 72 plus 87 plus 90 equals, that is $327. So I have $327 plus x. Okay, and what's 82 times 5? 82 times 5 is 410. And now, how do we undo this addition of 327? We're going to subtract it from both sides. Okay, and 410 minus 327, there it is right there. So let's rewrite our inequality, and the 327 minus the 327 cancels, leaving the x, and x is less than or equal to 410 minus 327 is 83. All right, so how much can Elvira spend on the fifth order to keep the average order within her budget? She can spend up to and equal to $83. So I should say she has to spend less than or equal to $83. So describe in words the quantities that would work in this situation. So again, we could say that fifth order has to be less than or equal to $83. See what I did? Elvira can spend up to $83. Nice. So write your answer in both interval and set notation. All right. My favorite, the interval notation, starts with a comma. And my left bound, well, Elvira could right now spend $0. Maybe they gave her a bonus on the fifth order. 0 on the left and up to $83 on the right. And if they gave her a big bargain and you get your fifth order for free, that's a bracket right there. 0. And I see an equals right there at the 83, so I'm going to put a bracket right there. So x is in the closed interval from 0 to $83. All right, set notation. All right, let's write our double inequality again. And it's this, but I need my left bound. So we're talking x's. And 0, it's this left bound right here, has to be less than or equal to x. And x has to be less than or equal to, what's my right bound? 83. And there you go. Okay, let's go ahead and close this one out, and we'll get started on the number 4 in just a second. Okay, number 4. Elvira can purchase ready-made pizzas for $14.50 each. Let's write an expression for that where we would probably have a variable x. It would need to be the number of ready-made pizzas. Or you could just say number of pizzas. So the number of pizzas would be $14.50 each. So I'm going to say 14.5x. Okay, if you wanted to go 0.50 there, you could. All right, so that's her cost if she buys the pizza ready-made. If she makes them in the cafeteria, she can spend $44.20 on ingredients. So that's just a cost for ingredients, and $6.25 or $6.25 per pizza. Okay, so let's think about this as her cost for ingredients is $44.20, and then her additional cost per pizza is $6.25 per pizza. So let's go plus 6.25x. Just like that. Now, you know what Elvira's thinking. What's going to be cheaper, to buy ready-made pizzas, or do we make them ourselves in the cafeteria? So let's know which expression goes with which. Okay, this 14.5x, that's the cost if we buy the pizzas ready-made. And this $44.20 plus $6.25 per pizza, that's the cost if we make them in the cafeteria ourselves. All right, now let's answer the question with an inequality right here. For how many pizzas is it cheaper for the cafeteria to make the pizzas themselves rather than buy them ready-made? So we want to know when this expression is less than this expression. So picture your inequality, less than. Okay, if I read it from here, 4420 plus 6.25x has to be less than 14.5x. Now I could have said that, then 14.5x is greater than 4420 plus 6.25x. So there's my inequality right there. Okay, and now what do we need to do? We need to solve for the number of pizzas x. So first thing we're doing is getting rid of, and here's what's going on here. Look, I have 14.5 x's on the left and I have 6.25 pizzas or x's on the right. All right, so I'm going to get my x's on the same side. So let's bring down our greater than right here. And again, I'm going to get my calculator out. Okay, yeah, I know you guys could do this in your head, but let's be really careful here. 14.5 minus 6.25, how many x's would that be? That would be 8.25x is greater than, and over here on the right, the plus 6.25x and the minus 6.25x cancel, leaving the $44.20. Now, you're going to divide both sides by, you have to undo this multiplication right here. Let's divide both sides by 8.25. Boy, another calculator moment here. So that doesn't change the orientation of my inequality symbol. We're still greater than. And on the left, the 8.25's cancel, leaving my factor of x. So x is greater than $44.20 divided by $8.25. 8.25. And I'm getting, again, this decimal 5.357575758. Wow. I better round that to the nearest pizza. So how about $5? X has to be greater than $5. Or excuse me, 5 pizzas. $5. Make sure you know what X is measuring here. Number of pizzas. All right. Now, describe in words the quantities that would work in this situation. Well, the number of pizzas has to be greater than 5, right? Let's see. The cafeteria would need to make more than 5 pizzas. And now my favorite part, write your answer in both interval and set notation. As soon as I see the word interval, I'm thinking count a comma right there. Okay. Now, x is greater than 5. That means, okay, my number of pizzas has to be more than 5. That means my bound on the left is, for the first time today, a 5. It's not that 0. And how many pizzas can we make if x just has to be greater than 5? I don't know what kind of time we have, so I'm just going to go on and on and on. I'm going to say infinity. Now, here's a key right here. So far today, we've gone bracket, bracket every time. But x is greater than 5. There's no equals right here. So this will be a parenthesis. All right? And because we can never reach infinity, I'm going to go parenthesis on the other side too. So this is the open interval from 5 to infinity, meaning x can not equal 5 pizzas, and we can never reach infinity. All right? Now, set notation. Well, if my lower bound is f and I'm just going forever to the right, my set notation is already up here. X has to be greater than 5. This is not a double inequality. X greater than 5. That's it. Okay? So, let's practice graphing inequalities now too. So, if you're asked to graph an inequality, start with a horizontal number line. And then your key number on this number line will be a 5. Put a hash mark and label that hash mark 5. Now, you need to know what kind of dot you use when there is no equal sign. X is greater than 5, so we use an open dot on the 5. That's a boundary. X cannot equal that 5. That's why we leave it open. And then greater than, which way are we going? Well, the numbers greater than 5 would be to the right. And that's how you graph. And then let's label this. That's the number of pizzas x right here. So we have interval notation, we have set notation, and then we have a graph. Those 3 things all say the same thing. Isn't that cool? All right, number 5. Elvira is comparing prices between 2 different suppliers of fresh lettuce, and she wants to know who's going to give her the better deal. So Val's Veggies charges $250 for delivery plus $1.50 per bag of lettuce. So it looks like my variable would be the number of bags of lettuce that we're going to buy. So we have $250 plus $1.50 per bag of lettuce, 1.5x. And there's Val's Veggies cost right there. Now, Sally's Salads charges $100 for delivery. So let's go 100 plus $4 per bag of lettuce. Can I go plus 4x? And now, how many bags of lettuce must be purchased for Val's Veggies to be cheaper, the cheaper option? So remember, we have Val's on the left and Sally's on the right. And if we want Val's to be cheaper, then this expression would have to be less than the 100 plus 4x. Let's solve this now for x. So notice I have x's on the left and the right. Let's get the x's on the same side. So how about we subtract 1.5x from both sides of this inequality? Less than. So that's 250 plus 1.5x minus 1.5x is 250. And on the right I have 100 plus, what is 4? Well, let's go 100. What is 4x minus 1.5x? Well, wouldn't that be 2.5x? There you go. Now we have a two-step inequality. Let's get rid of the 100s. Let's subtract 100 from both sides. Less than, and 250 minus 100 would be 150 is less than 2.5x. And now you guys know you're going to divide both sides by 2.5. Does not affect the orientation of our inequality. We divided by a positive number, and 150 divided by 2.5 is 60. Hey, a whole number, look at that. And on the right, my 2.5's cancel. So I'm going to read this from the variable. X is greater than 60. You could say 60 is less than x, but most people find it's easier to read an inequality from the variable. X is greater than 60. So x has to be greater than 60 bags. Okay, B. Describe in words the quantities that would work in this situation. Well, essentially the way I read this just described it. So we need to buy more than how many bags of lettuce for Val's to be cheaper than Sally's? 60 bags. Now write your answer in both interval and set notation. So interval notation, comma. Okay, now more than 60 bags. That means my left bound would be the 60. And my right bound, well, I don't know how many more I'm going to buy, so let's go to infinity. And more than means we cannot equal 60, so I have to go parenthesis. And I can never reach infinity, so I have to go parenthesis on that side too. So this is the open interval from 60 to infinity bags of lettuce. Now set notation. Well, set notation, we already have it up here. X is greater than 60. Okay, good. And now let's practice graphing again. So, my hash mark, how am I going to label that? 60. Greater than what kind of dot? That's got to be an open dot. I cannot equal 60, so I have an open dot there. And since x is greater than 60, I'm going to go to the right. And what is this interval right here? X is greater than 60. That's the number of bags of lettuce, which we're using an x for. Number of bags of lettuce, x. Okay, the last problem. Well, this is going to be fun. So, each student that buys school lunch pays $2.75. So that would be, how much money is coming in? $2.75 for every school lunch sold. So how about 2.75x? 2.75 times the number of students who buy a school lunch. the cafeteria typically brings in between $1,168.75. So I'll put that bound over here on the left. And on the right, I have $1,438.25. Let's put that pound on the right. And now brings in between, all right? Now, if you did this as an open interval or a closed interval, I probably couldn't argue with either, but I'm thinking I want to go closed here. So I'm going to say $1,168.75 is less than or equal to 2.75 times x, and that is less than or equal to $1,438.25. And now, solving a double inequality is just as easy as solving an inequality. You just have three sides. So, if you're going to isolate this x right here, the first thing you're going to want to do is divide all three sides by that 2.75 to undo that multiplication right there. So I just do all three sides divided by 2.75. Now we divided by a positive, so the orientation of our inequality symbols does not change. And on the left, well, I better get out a calculator. Let's do this carefully now. And what's being, these are dollars, right? How many students does the cafeteria use? So this is number of students, so I'm going to want whole numbers here. Let's see if that's what I did. 1168.75 divided by 2.75, and I'm getting 425 exactly. Well-written problem. And in the middle, the 2.75s cancel, leaving x. And on the right, I should get a whole number again. If this is a legit problem, 1,438.25 divided by 2.75 and 523. So what's happening? Every day between 425 and 523 students inclusive are being served lunch at this school. Wow. Look, I always read that to you, and then B, describe in words the quantities that would work in this situation. Hey, we just did that. Every day the cafeteria serves between 425 and 523 students. Okay, now write your answer in both interval, comma. What's my left bound? Well, this is easy, 425. What's my right bound? 523. Now, do I see equals there? I do on both ends, so that means I'm going to go bracket, bracket, and there's my interval notation. Now let's say the same thing with set notation, and we have already done that right there. So let's just rewrite that here. 425 is less than or equal to x, and x is less than or equal to 523. Now, finally, for extra practice, let's graph. Now, this is a double inequality right here, so to graph it, I'm going to need two hash marks. Guess what I'm going to put underneath the hash mark on the left? That's right, my left bound, 425. How about on the right? My right bound, 523. Now, equal, equal. Here's the key. You haven't seen this yet. When there's not an equal, my dots are open. But if x can equal 425, solid dot. And x can equal 523, solid dot. And we're talking all my x's are everything in between and including those two bounds. There it is right here. And what is that? That is the number of students buying school lunch, x. I hope you guys enjoyed this as much as I did. Get your ready, set, go done, and you guys have a great day. Thank you.